So today what we're going to talk about is a continuation on graphing systems of inequalities, and we're going to start defining some new terms. So our first new term is Polygon of Constraints. And what that is when we have a system of inequalities in two variables like x and y or r and m, like our example that we did in class the other day, and it represents a set of constraints. The graph of the solution set is called a polygon of constraints. So here we have two sets of inequalities, and these could represent anything from the word problems that we've been practicing. So perhaps we have a word problem and we get this set of inequalities on the left. So y is greater than or equal to 7, y is less than or equal to x plus 2, and y is less than or equal to negative 1 over 2x plus 15. And we have these additional constraints that x has to be greater than or equal to 0 and y has to be greater than or equal to 0. So if that was our set of inequalities, and we wanted to graph them all together, we would get something that looks like this. Okay, so these are our three lines, and we also have our constraint that everything has to be greater than or equal to 0 in the x and in the y. And what that looks like is the fact that we're graphing only in the first quadrant. So because we have this x has to be greater than or equal to 0, and y has to be greater than or equal to 0, we only have the first quadrant of our graph. And what we notice here is we end up with this bounded area. That's what we call this. We call this a bounded polygon of constraints. And it means that we end up with a very distinct shape isolated by all of these different inequalities. So everything within that polygon is part of our solution set. For our other system of inequalities, we have y is greater than or equal to negative x plus 10, and we have y is greater than or equal to negative 3 over 2x plus 14. With the same constraint that everything has to be in the positive x and the positive y, we get something that looks like this. And we call that unbounded. So whenever we have a system of inequalities where the polygon is not bounded into a small shape that we can see on our graph, it continues on forever and ever, we call that an unbounded polygon of constraints. And that looks like what we've been graphing for the past little while. So you can see the difference between the bounded and the unbounded polygon of constraints. So that x greater than 0 and greater than or equal to 0, and y greater than or equal to 0, these are called our non-negative constraints. And the reason that we have them is that for most problems, the only values that make sense are positive values. And I've written an example down here. We did a question in class about booking buses for a school trip, and it would not have made sense to have negative values for x or y because x and y represented the amount of large buses and the amount of small buses. So it didn't make sense for us to have negative x or y values. So we see these constraints showing up, and often our graphs are only in the first quadrant because that's the only quadrant that makes sense for our values. So whenever we have a bounded polygon of constraints or an unbounded, we have edges that connect our different inequalities. So to find the coordinates of these vertices in our polygon of constraints, we need to solve our system. So if I gave you just a set of inequalities, there's more than one way that we could actually solve to find those vertices. So three ways that we can solve. We can do a table of values, so we can choose different values of x and determine where our coordinates connect for our different inequalities. We can also graph our system of inequalities, which is the method we're going to be using in our next class. And we can solve algebraically. So that means actually using algebra, rearranging and using the methods for a system of inequalities. Our vertex can either be a part of our solution set or it can actually not be a part of the solution set. So what does that look like?